Welcome pre-calculus students to class today on Monday the 16th. Hope you guys are doing well. Hope you're ready to learn some math today. Hey, just 4 more days of class, Monday, Tuesday, Wednesday, Thursday. Then you can take your final exam on the Friday if you would like to, or any time after that. Have a nice 2-week break, and then our first video, I believe, will be January 7th. So good job on the first semester. You're halfway done, and keep working hard, okay? I'm still waiting for 2 of you to give me test number 8. And so I need you to take care of that, okay? Please get test number 8 in. And as I just said a second ago, you can start taking your exam if you would like to on Friday. Now, you've got to let me know whether or not you're going to take it at my house or at your house. And I don't need to know right away, but do let me know. And if you are going to take it at my house, give me, at least a day or 2 notice so we can work things out. With making sure someone's here and all of that, okay? Well, without any more hesitation, let's go ahead and take a look now at test number 5 today. Let's first review. Here's test number 1. I mentioned knowing these 6 definitions, be able to put them with the correct numbers. Also on test number 1, we mentioned all this stuff here. You can look at it later, but I'm trying to give you a list of stuff to go back and study and look at your tests. Scientific notation, exponential rules, polynomials, add, subtract, multiply, finding domains, factoring, stuff like that. And then test number 2, trig values, finding angles, degrees, minutes, and seconds, cofunctions, etc., multiplying and dividing rational expressions, adding and subtracting rational expressions, and then solving some different types of equations there. And then test number 3, solving right triangles, finding the terminal side of a given angle, positive, negative coterminals. You can read all these on your own, complement and supplement of a given angle, etc. So be sure and look all these over. And then what I like to do is whatever the last test was that we covered, in this case it was test number 4, on Friday, I like to review that test just one step at a time, and that's what I've been doing every time. So here we go. Be able to find arc length or radius or the central angle when given 2 of these measurements. And of course we're talking about a situation like this where you have a circle and a central angle, we'll call this theta, and an arc length s and a radius r. And the formula is theta equals, is it S over R or R over S? I am your teacher and I know that, but I get those confused. I'm pretty sure it's S over R. But either way, you have that formula from your notes. And so make sure you're ready to solve those types of problems. Be able to graph sine and cosine functions, something like this. Y equals 2 sine 3x plus 90 degrees minus 5, something like that. I gave you 7 steps to solve those, okay, or to graph those, excuse me. Number 3, be able to factor trig expressions. Number 4, be able to find exact trig values by using sum and difference identities. Now you're more than welcome to have what I call a cheat sheet for your exam when it comes to your trig identities. You're more than welcome to have that with you when you take the exam. Also, you're welcome to have this also on your exam. Let me see if I find it right here. Hold on one second. You're also welcome to have this on your exam too, if you would like to, okay? So keep that in mind. Okay, now be able to find trig values by using those identities, also by using double angle identities, also by using half angle identities, and this is test number 4 that we covered, okay? All right, let me grab a quick drink here, and let's go ahead and get started. We're going to take a look at test number 4. If you have test number 4, go ahead and get that out. And if you don't, that's totally fine, okay? You can just follow along and take some notes. Okay. We're going to solve numbers 1 through 4 and 5 also. Your answers must be exact numbers. So let's start off with number 1, okay? The problem says tangent of inverse tangent of negative 4.2. Now, here's what we're going to do. We're going to rewrite the inside here. We always start inside the parentheses or inside the brackets first. You should know that from algebra, okay? And so whenever we see inverse tangent or inverse cosine or inverse sine, it simply means to rewrite it like this. There we go. Okay? So basically, inverse tangent means find the angle that when you take the tangent of that angle, you get 4.2. Isn't that easy? That's all you have to do. Whenever you see inverse tangent, you rewrite it as tangent of x equals whatever this number here is. So it's not that hard. So whenever it says inverse tangent, you're looking for an angle. Please don't forget that, okay? So if you look at your table, we're trying to find an angle that gives you 4.2. Notice there's no angle on here that when you take the tangent of it, you get 4.2. So we come back here, and what we're going to do is we're going to use our calculators. Now I know it says your answers must be exact numbers, but just trust me, watch what happens here, okay? With your calculator, if you type in second tangent of negative 4.2, you're going to get out this right here. You're going to get out tangent of negative, sorry about that, hold on one second, there we go, negative 76.60750.225. Now don't clear that off your screen, please. Do not clear that off your screen. Leave that whole thing on your screen, okay? So you're looking for an angle here, so you hit second tangent of this number and you get a really long angle. Now leaving that number on your screen, now take tangent and then use your answer button. On your scientific calculator, there should be an answer button. So you take tangent and then hit answer of that exact decimal right there, and you're going to get negative 4.2 exactly. Now I'm not going to go into a really long explanation. Some of you can see that automatically that it makes sense. Others of you might not, and that's fine, okay? But let me just say this. To me, this makes total sense because you're saying to yourself, okay, I'm going to find an angle that when I take the tangent of that angle, I get 4.2. Okay? And then when you find that angle, you turn around and you take the tangent of that angle, so obviously you're going to get negative 4.2. To me it makes total sense. But if you don't see it that way, that's fine. Just remember that when you see inverse tangent, or in other words, tangent to the negative 1, you write tangent of an angle equals whatever the number is, and then type that into your calculator or use your table if it's on your table, and then take whatever's on the outside of that angle. Okay? Let's go ahead and try a couple more here. Let's try number 2. Number 2, inverse sine of 2 pi over 3. Now the first thing I'm going to do is I'm going to write this. I'm going to start inside the parentheses like I taught you, and I'm going to write this. I'm going to write the sine of 120 degrees. For us, degrees is always a lot easier. Okay? Now, 120 degrees, that does not appear on our table. But actually it does. Remember, the sine of 120 degrees, now come on, think about this, guys. If we rotate 90 plus 30 more, we have 120. So there's 120 degrees right here. 120 degrees. That leaves us with 60 right here. And remember, you can take the sine of 60 instead of 120 as long as you remember what quadrant you're in. And the sine sequence in this quadrant is positive, negative, negative. In other words, sine is positive in this quadrant. So instead of taking the sine of 120, you are more than welcome to take the sine of 60 because 60 is the reference angle for 120 as long as you remember that sine is positive in this quadrant. So I know I'm going to get out a positive answer, and instead of taking the sine of 120, I'm going to take the sine of 60. And here it is. The sine of 60 is square root of 3 over 2. Sine of 60 is square root of 3 over 2. So I'm going to put square root of 3 over 2. There we go. Everybody see that? I took the sine of 120, which is the same thing as the sine of 60, and if you use your table, you'll get this. Now look what you're left with. You're left with this right here. Well, did I not just mention to you a minute ago that whenever you have inverse sine, that means sine of an angle equals whatever you have here? Well, students, we can definitely use our table. The only thing I want to remind you of that we really do need to review is whenever you're dealing, well, let me finish the problem and then I'll get to that. So we're saying to ourselves, what angle when you take the sine of it gives us square root of 3 over 2? Well, here it is, 60 degrees. Sine of 60 gives me square root of 3 over 2. square root of 3 over 2. Okay? And that makes, I'm sorry, I apologize to you, my fault. Sine of 60 gives us square root of 3 over 2. So x would be 60 degrees. Sine of 60 is square root of 3 over 2. Now, that makes total sense to me. You took the sine of 60 and you got this out, then you said to yourself, sine of what angle gives me this? Well, it's going to be 60. Okay, to me that just makes sense. Now, there is one thing I want to mention to you before we go any further. Okay, so the answer here would be 60 degrees. Whenever you're dealing with inverse sine, inverse cosine, and inverse tangent, we talked about this before. You're dealing with these two quadrants here and here, and for tangent you're dealing with these two quadrants here and here. For cosine you're dealing with these two quadrants here and here. So for sine it's quadrants 1 and 4, for cosine it's quadrants 1 and 2, for tangent it's quadrants 1 and 4. Now when I say you're dealing with those quadrants, what I mean is whenever you take the inverse sine or inverse cosine or inverse tangent of a number, your answer should fall in one of these two quadrants. It has to, okay? So keep that in mind, and we'll talk more about that later, but we did cover that in class. That's very important that you understand that, okay? All right, let's continue on. Let's take a look at number 3. Let's start inside the parentheses. So I have cosine on the outside, and then inside I'm going to have sine of angle x equals square root of 3 over 2. All right? Do you see how I rewrote that? Inverse sine means sine of x equals square root of 3 over 2. So I'm looking for an angle that when I take the sine of it, I get square root of 3 over 2. Let's see. Here it is, 60. Sine of 60 is square root of 3 over 2. So now I have the cosine of 60. Because remember, students, I'm going to say this again. Whenever you're finding or solving an inverse trig function, you're solving for an angle. You're finding an angle. And so we found the angle at 60. Now what is the cosine of 60? Well, let's see. Cosine of 60 is 1/2. There we go. So the answer would be 1/2. All right? Not too bad. All right, let me grab a quick drink here and we'll continue on. Okay, number 4. Now, number 4, we're going to start inside. And let me erase this real quick. So for number 4, we're going to say we have cosine. And then we're going to say inverse tangent, which means you're looking for an angle. So tangent of x equals square root of 3 over 4. All right? Square root of 3 over 4. Now, we go to our table here, and we look, and I'm not seeing a square root of 3 over 4 anyways, okay? Anywhere, excuse me. So, we're going to come back here, and we're going to say to ourselves, okay, Mr. Earhart said we have to use exact answers. Okay, and this is not going to be super easy to do here. So, if I can't find this angle x, what am I going to do? Well, remember, first of all, and I'll follow my reasoning carefully, listen to me carefully. Inverse tangent, remember, means we're dealing with the first and fourth quadrants. Okay, that's number 1. Tangent is negative here, tangent is positive here. Okay, and we're looking for an angle that gives us square root of 3 over 4. Now I don't know what that angle is. Do you see what I'm saying? I don't know what that angle is, but I do know I'm in the first quadrant because I'm trying to find an angle, tangent of an angle that gives me out a positive answer. So I know whatever the angle is, it's going to give me out a positive answer. Thus that will put me in the first quadrant. So here's my angle. I'm going to call it x. And actually I do know a little bit about this triangle. Tangent is opposite over adjacent. So there, opposite over adjacent. And now I can find the third side pretty quickly by finding the hypotenuse, the square root of, remember, this is Pythagorean Theorem, square root of 3 squared plus 4 squared. Now that's going to give me the square root of 3 is 3, square 4, that's 16. So I'm going to get square root of 19. Does that make sense? Now, well, Mr. Earhart, how does all that help? Well, I'm glad you asked. Thanks for asking. Did I ever find what this angle is? No. Look, here it is, x. We have no idea what x is. So I'm going to say the answer to this part of the problem right here, since I never could find the angle, I'm going to call it x. So now I'm trying to find the cosine of x. Remember, again, students, whenever you solve an inverse tangent, you're solving for an angle. So this whole problem right here, or this part of the problem, means I'm looking for an angle, and I never could find the angle, so I'm going to call it x. And guess what? I'm okay with calling it x, because what is the cosine of x? Well, if we come over here and look, here's x. Cosine of x is adjacent over hypotenuse, so the cosine of x is 4 over square root of 19. Now we're going to multiply the top and the bottom by the square root of 19, and our final answer would be 4 square root of 19 all over 19. There we go. You solved it using exact numbers. Okay? Really cool and not that hard, as long as you take it step by step and break it down. Okay, let's take a look at number 5 and we're finished with this page. Number 5 says write your answer in terms of x, okay? This will be a little tougher, but let's see if we can't tackle this, okay? We have tangent of, and then inside it's an inverse cosine, so I'm going to put cosine of x equals 3 over x. Now obviously, since we have an x here, in fact, actually I better make this a y, because there's no way I want two unknowns in the same problem. So in this case, we're going to call this y. But anyway, students, if you'll look here, there's no way this is going to be on our table right here. It has an x in it. It's not even a number. So there's no way we can even solve for y. But what we can do is this. We can say, okay, I'm looking for an angle called y in such a way that it gives me out a positive 3 over x. Now if it gives me a positive 3 over x, I know that cosine, when I'm dealing with inverse cosine, deals with my first quadrant and my second quadrant. I know that cosine is negative here and cosine is positive here. So I'm going to deal with the first quadrant because I'm getting out a positive 3 over x. So I don't know what my angle is, but I can call it y. Okay? And I know cosine is adjacent over hypotenuse. Now, using Pythagorean Theorem, I can very quickly find this leg over here. So I have one of my legs squared plus my other leg squared. I have no idea what that leg is. We're going to call it L, and my hypotenuse is x squared. Now I'm going to solve for L. So I would have L squared equals x squared minus 9. See where the 9 came from? 3 times 3 is 9, and then bring it over to the right side. And now I'm going to take the square root of both sides. And I could put plus minus, but remember, the length of a triangle is never going to be positive or negative, so I'm just going to leave that alone. And I'm going to put the square root of x squared minus 9. Now some of you think you can simplify that. Oh, I'm going to take the square root of x squared or the square root of 9. No, that's two terms. You have two terms inside the radical, so don't do that, okay? You leave that alone. So your leg right here is going to be x squared minus 9. So do you not have all three parts of your triangle now? Sure you do, definitely. And so what we did is this. Remember, folks, remember, students, whenever you're trying to find an inverse cosine or inverse trig function, you're looking for an angle. And here's the angle right here, y. Did we ever find that angle value? No, we didn't. We're going to call it y. So now we're going to take the tangent of the angle value up here, which is y. And since we have our entire triangle, this is not going to be very difficult. Tangent of y is opposite over adjacent. Opposite over adjacent. So my answer is square root of x squared minus 9 all over 3. There's your answer. And so we actually, Mr. Eric, can that be an answer? Well, sure, look at your directions. Your directions say write your answer in terms of x. In other words, you're going to have x in your answer. That's totally acceptable. Okay? All right, if you need to play this back a couple times, feel free to do that. Let's go ahead and move on. Let me grab a drink here. And that's the first 5 problems on the review today. Let's continue on. Okay, we're going to prove these two statements, and I know by now that you've come to really hate these. I know they're tough, but really just do the best you can. Okay, that's all I can say on the test. You'll have your Trig Identities cheat sheet with you. All you can do is just try to figure out little steps and little things along the way to help you break these down. For example, let's prove this Trig Identity. Whenever I have two fractions equal, I like to cross multiply. So I'm going to take cosine times cosine, that's cosine squared, equals, and then I'm going to multiply 1 minus sine times 1 plus sine. Now remember, that's going to be 1 times 1, 1 times sine, and then negative sine times 1, negative sine times sine. So I'm going to take 1 times 1, that gives me 1, and then I'm going to take 1 times sine, that gives me sine. And now I'm done with my 1. I'm going to cross it off. Now take your negative sine and multiply it through. Negative sine times 1 is negative sine. And then negative sine times positive sine would be negative sine squared. Not too bad, okay? So I have totally done my cross multiplication. And now, to be honest with you, I'm seeing two terms here that cancel out. I mean, a positive sine and a negative sine x. So I'm going to quickly grab those and just pull those over here. They're gone. And then that's going to be tough to do, and then slide this over. Okay, everybody see what I did there? Now, this actually is a pretty simple trig proof here, guys, because if you'll look at your trig identities, you should have somewhere that sine squared plus cosine squared equals 1, right? And if you were to take that trig identity and bring the sine squared over and make it negative, you would have this right here. Cosine squared equals 1 minus sine squared. So you can make a substitution right now. 1 minus sine squared equals cosine squared. And you're done. That's it. So look that over. That's not too difficult, okay? It's decently simple. Alright? Okay, let's continue on, and let's try to prove this trig identity over here, or this trig equation. Now, again, we have two fractions equal, so I'm going to cross multiply. I'm going to take cosine times this term, and then cosine times negative 1. So cosine squared times tangent squared is going to give me cosine squared tangent squared, and then cosine squared times negative 1 is going to give me negative cosine squared. And I might not have left enough room there. Sorry about that, students. Well, we'll just leave it alone for now. Okay, so I took cosine squared and multiplied it times this up here. Now we're going to cross multiply the other way, so you know it's going to be sine times sine. This sine right here, sine times sine, then sine times cosine, and then negative cosine times sine, and negative cosine times cosine. Okay, let's go ahead and cross multiply. I'll try to write really small here, and actually we are going to need some more room, so we're going to slide this up and then pull this over and get a little more room. Alright, and having done that, here we go. Alright, sine times sine is going to give me sine squared. And then sine times cosine is going to give me a positive sine cosine. Cross off your sine. And then we have negative cosine times sine. That's going to be a negative sine cosine. And then negative cosine times positive cosine will be a negative cosine squared. Okay? So not too bad, and if you look right in the middle, these two terms are going to cancel out. Positive sine x, cosine x minus sine x cosine x. So let's see if we can't quickly get rid of these two middle terms right here. And then slide this over. Now here's where students get frustrated, and as a teacher it's pretty difficult too, because there's really no steps you can teach. You just have to look this thing over and look it over and look it over and say, what can I do here to make this thing the same? Now I wish I had sine squared plus cosine squared. If I had a plus sign there, then I would make this side 1 and then start working over here to make this side become 1, but that's not the case. So I'm looking and I'm saying to myself, okay, self, is it easier to put these two together, eliminate something over here so I just have one trig function minus one trig function? I'm looking all this over, and one thing I see is this. Okay, watch this. I see that I have a negative cosine squared here and a negative cosine squared here. So that's good, okay? If somehow I could change sine squared to cosine squared, tangent squared, or vice versa, that'd be great. And as I looked at this expression right here, I remembered something. Now watch what I do here. I'm going to put cosine squared over 1, okay? And remember, these two are multiplying. They're side by side, so I'm going to put multiply. I remember that tangent is the exact same thing as sine over cosine. So if I have tangent squared, then tangent squared is the same thing as sine squared over cosine squared. And then bring down your negative cosine squared x. Alright? Now if I multiply these two together, would you please look at what happens? Cosine squared cancels with cosine squared. So 1 times sine squared would be sine squared, and 1 times 1 is 1. I'm not going to worry about the 1 because it's in the denominator, and sine squared over 1 is just sine squared. So 1 times sine squared is, look what I have. I have sine squared, and then bring down your negative cosine squared, equals, and then you can bring this entire expression down, and there we go. Sine squared minus cosine squared equals sine squared minus cosine squared. So as you can see, although I'm not criticizing you if you missed these on the test, but they were not that difficult. They were definitely reasonable, okay? And I will try to be reasonable on the test and just give you some that basically test your basic trig identity knowledge and your manipulations of what to do with those, okay? Alright, let's continue on. So what we've reviewed so far is inverse trig functions, inverse tangent, sine, cosine, and what to do with those, okay? And then also we've reviewed trig proofs, okay, proving trig statements or expressions. And now let's go on and let's go ahead and take our product to sum and our sum to product identities, and let's see if we can't make some new identities here, okay? So if you've got your trig identity sheet, or if you have to turn to the back of the book, whatever you need, go ahead and get those out. Now hopefully you've located your sum to product and your product to sum identities. And let's go ahead and take a look at number 8. Notice I have a product. Everything's being multiplied. So students, I'm not going from a sum to a product. I have a product. I'm going from a product to a sum. In other words, I'm starting with the product and I'm rewriting it as a sum. So the identities you want to look at for number 8 would be product to sum. Now if you look at those identities, notice I have a cosine times a sine. Yes, I know there's a 3 up front. I'm not worried about that. I have a cosine times a sine. So if you look at your product to sum identities, there is only one that says cosine times sine. Okay? And here's the idea. I'm going to write over here. The identity is cosine of x sine of y equals, and I'm copying it right now out of my book, 1/2, and then bracket, and then sine of x plus y minus sine of x minus y. So there we go. Students, if we can very simply take this trig identity and apply it over here, we'll be doing great. Now the first thing I'd like to show you is don't worry about the 3. See the 3? Cross that off. You can bring that down here for your final answer, okay? So we'll just bring the 3 down and we'll apply that to our final answer. Okay, fair enough. Now, it says cosine of x, sine of y. Well, look at this. I have cosine of 2x. So in this problem, are you watching? In this problem here, my x right here is going to equal 2x. So my x equals 2x. Do you see that okay? Look right here. Here's my trig identity. When you have cosine of x, sine of y, you can rewrite it like this. So I'm going to call my x 2x, okay? And look at this. My y right here, my y, I'm going to call that x. So my y equals x. Now, Mr. Earhart, why are you writing that out? Because it's going to be so helpful when we make our substitutions over here. Cosine of x, sine of y equals all of this. So if it equals all of that, I'm going to go ahead and put 1/2. If I get my pen to work here, hold on one second. It's going to be 1/2, and then my bracket, and then sine, and then look, students, sine of what? X plus y. What is my x? It's 2x plus, what is my y? X. When you write it down like that, it makes it so easy. Minus sine of x minus y. Well, my x is 2x minus my y is x. And now all that we have to do is simplify this, and we will have taken a product and rewritten it as a sum, where we have two different terms over here. So I have 1/2, and then inside the brackets I would have, are you ready? Sine of 3x, 2x plus x is 3x, minus the sine of x, because 2x minus x is x. And now take your 1/2 and multiply it through. So you would have 1/2 sine 3x minus 1/2 sine of x. Not that hard, but hold it. Remember, the very original problem up here had a 3, remember? And we brought that 3 down, and we said, hey, we're going to put 3 with our final answer. So what we have to do is we have to take this answer that we got here, and we have to bring it over. Sorry about that. We have to bring it over, and you have to multiply that entire expression by 3. I mean, that makes sense to me because you've got a 3 here that you brought down. So I'm going to write your final answer right here. Okay, you multiply 3 times this term right here. 3 times 1/2 is 3/2, so 3/2 sine 3x minus, and then 3 times 1/2 would be 3/2 sine x. You did it. You took a product and you wrote it as a sum. If you need to watch that again, feel free to do that. Now, number 9, notice we're not starting off with a product, we're starting off with a sum, or in other words, two terms, okay? And so we're going to use the sum to product identities. So look in your Trig Identity sheets and see if you can find your sum to product identities. And I have my book right here in front of me, and the only one that I see that says sine minus sine is this one right here. Are you ready? And you should have this on your Trig Identity sheet. If you're having a hard time finding these, you can locate these. I guess I should have told you this a little earlier. Page 561 is where you'll find these. But sine of x minus sine of y equals, and why did I use this one? Because I have sine minus sine. Sine minus sine equals 2 cosine x plus y over 2, and then sine of x minus y over 2. Okay, there's your identity. Now please watch this carefully. What this expression is saying is when I have sine minus sine, I can rewrite it like this. So sine of what? X. What do I have here? X. So my x equals x. So I'm going to go ahead and write x equals x. Now, minus sine of y. Well, I have minus sine of 4x. So my y here really equals 4x. So my y equals 4x. So now when I make my substitutions over here, I'm going to use these values for x and y. So I would have 2 cosine x plus y. Well, x is x and y is 4x. So I would have x plus 4x all over 2, and then sine of x minus y. Well, x is x and y is 4x, so I would have x minus 4x all over 2. I think just about one more step and we're done. Next we would just simply write 2 cosine x plus 4x is 5x, so we would have the cosine of 5x over 2, and then sine, and then x minus 4x is negative 3x. So I'm going to put it in parentheses since it's negative. It'd be negative 3x over 2. and that's it. Please don't take the 2 and multiply it through. You would only do that if the trig identity, well, even then, even if it looked like this is one term. There's no plus or minus sign right here in between the two fractions, so there's nothing else you can do. And look what you did. You started off with 2 terms that were being subtracted, and you wrote them as a product. Your final answer here has a cosine times a sine. So you did it. That's all I want you to do in these, okay? Just be able to take your product to sum and your sum to product identities and rewrite given identities. All right, let's continue on. Just to encourage you students, we're just about done. I believe this is our last page. Let me slide down and look. Yeah, this is it. So let's whip through these quickly. I'm going to grab this here and knock it down to here. There we go. That'll help us a little bit. Okay, now a couple things. Notice in the directions it says solve these, give answers in degrees and radians, and nowhere does it say use exact numbers. So I'm okay with calculators, but can I say one thing right now? I don't have to tell you to use exact numbers. You should know by now, anytime any of these problems appear on your table, you are to use exact numbers, and I'm not going to be lenient on that. Okay, we know that by now. So first you always check your table and use it, which is easier than a calculator in my opinion. Okay, and then number 2, if you can't use this and the directions did not say to use exact numbers, which the directions did not say to, then you can use a calculator. But always check your table first. Let's start off with number 10. Number 10 says inverse of sine equals negative 1/2. Now watch this, watch. That means sine of x equals what? Negative 1/2, right? We learned to rewrite our inverse functions like this. So I'm looking for an angle that gives you a negative 1/2. Now if it was positive, that would be easy. We would just come over here, sine of 30 is a positive 1/2. But be careful, it's a negative 1/2. So remember, inverse sine deals with quadrant 1 and quadrant 4. Are you with me? And we know which one is negative. Sine is positive here and sine's negative here. So I know I'm dealing in this quadrant here, so I'm going to go ahead and draw my triangle here. Now, don't worry about the negative sign for right now, or for this right now. This negative sign here was just telling me what quadrant to go to. Okay, so now that I know that I'm in the 4th quadrant, which I am, what angle does give me a negative 1/2? Well, let's see, 30 degrees, as long as I put it in the 4th quadrant. So 30 degrees. There we go. So if this is your answer, don't you dare put 30 degrees, because if you put 30 degrees, you're referring to this angle right here, 30 degrees, and that's not right. The angle we're talking about is this angle here, and remember, you would rotate down, which makes it a negative 30 degrees. You're in quadrant 4, so the answer is negative 30. And by the way, if you wonder if that's right, take your calculator and hit sine of negative 30. Go ahead and do that, and you'll see you will get out a negative 0.5, which is the same thing as negative 1/2. Okay, so these aren't too bad. Okay, use your table and know what quadrant you're in. All right, let's take a look at number 11. Number 11, we're going to rewrite it as cosine of a given angle x equals square root of 3 over 2. Now this is a positive square root of 3 over 2, so this should be pretty easy. We're just going to simply go to our table and look up square root of 3 over 2. Here it is right here, along with cosine right here. So cosine of 30 gives me square root of 3 over 2. Cosine of 30, and that was a mistake. There we go. Cosine of 30 is square root of 3 over 2. So I know my answer here is going to be 30 degrees, because cosine of 30 is square root of 3 over 2. Now, I did forget one thing. The directions said to write your angles in radians and degrees. So negative 30 is negative pi over 6. Positive 30 would be pi over 6. I'm going to do one of these for you quickly. I'm not going to do every one. You should know by now how to do this. Remember, if you have degrees and you're converting it over to radians, you multiply it by pi over 180, okay? And so 30 would cancel into 180 6 times. 1 times pi is pi, and 1 times 6 is 6. I have a lot of these memorized because I've done these for so many years, but do be able to convert these over. I want both answers, radians and degrees. Okay, tangent of negative 1 equals 1, or in other words, tangent of x equals 1. So I'm looking for an angle that gives me a 1. Let's see if it's on your table here. It is. Look at this. Tangent of 45 degrees is 1. Tangent of 45 degrees is 1. So that's pretty simple. My answer is 45 degrees or pi over 4. Okay, so there we go. So not too difficult when you understand how to rewrite these different inverse functions. All right, let's take a look now at number 13. Sine of -1 or inverse sine of 0. That simply means sine of some angle gives me 0. Now that's not on your table. You can look. We don't have that on our table anywhere, so use your calculator. So if you grab your calculator, and I am trying to locate mine. Now the only thing here, I want you to be careful about something. Well, I'll get to that in a second, but go ahead and hit inverse sine of 0 and you're going to get 0. So there you go. You found your answer. The sine of 0 is 0. So there. And of course, how many? 0 degrees and 0 radians. All right, there we go. Pretty simple. Now, be careful. We're getting into some negative signs here. Okay, so in number 14, let's be really careful. Inverse secant, or in other words, secant of a given angle x equals -2.1953. Okay? Now, let me say a couple things here very quickly. First of all, we don't have this on our table anywhere. You can look and see nowhere do we have -2.1, whatever that decimal was. So number 2, we're going to have to use our calculator. The problem with that is nowhere on your calculator do you have an inverse secant button. So we're going to flip this side. Remember, secant, let me write it over here for you, secant of x equals 1 over cosine. That's one of your trig identities. Okay? And so if that's the case, I can flip this side. I can say that 1 over secant equals cosine of x. So in other words, for secant of x, I can flip that and make a substitution. And just trust me, flipping secant is the same thing as putting cosine. But if you flip the left side, remember, even though you can't see it, this is really over what number? A 1. So if you flip the left side, you're going to have to also flip the right side. So now you have 1 over -2.1953. Now we can definitely use our calculator for that. Okay? Now as you type this into your calculator, I mentioned earlier, be careful. You have a negative sign here, so be careful to use your negative sign. Okay? So you're going to hit second cosine and then type this in. So when you hit second cosine, this should appear on your screen. And when you type this in, be sure and use parentheses, 1, then hit divided by, and then -2.1953. If you're in the degree mode and you type this in correctly, you should get 117.0983073. So I'm just going to put 117 degrees. Okay? Now I do want you to convert that to radians, and I do not have this one memorized. So 117 over 1 times pi over 180. I don't think there is a little bit of simplifying we can do. Let me see if I can figure that out real quickly here. 13 over 20. Okay, so 9 goes into 117 13 times, and 9 goes into 180 20 times. So it looks like to me radians would be 13 pi over 20. So there we go. So 117 degrees or 13 pi over 20. There we go. Really not too difficult. I mean, I'm not saying it's easy, but it's not tons of steps. Just understand what you're doing here, okay? Inverse cotangent. So that means cotangent of an angle x equals 2.381. Now, students, we don't have 2.31 on our table. Nowhere. So we're going to have to use a calculator, but nowhere on our calculator do we have a second cotangent button. So if you flip cotangent, you will get tangent. But if you flip one side, you must flip the other side. Remember, this is over 1. So when you flip it or invert it, you get 2.381. There we go. So with my calculator, I'm going to hit second tangent, So on my calculator, this should pop up. And then 1 divided by 2.381. I have not typed that in yet. Let me do that very quickly here. The second tangent, 1 divided by 2.381, and I'm getting out 22.78. I'm going to go ahead and call that 23 degrees. So 23 degrees. And then let's convert that over to radians. So 23 over 1 times pi over 180. I don't think we can reduce 23 and 180, but I will check very quickly. No, you cannot. So there's no simplification. So 23 times pi would be 23 pi. 23 times pi, and 1 times 180 is 180. So there we go. There's your two answers, one in degrees and one in radians. Okay, that's it for test number 5. I hope this has been a help to you. Please don't hesitate to call me or email me if you have any questions at all.